Breakdown documents a workflow for building procedural rooms and managing interior scenes using Houdini USD and multiple rendering engines. The focus is on parallel workflows, scene structure, asset organization, and cross-DCC usage rather than on a single final render. I start with a procedural approach to modeling the room structure, designed around a specific production pipeline. The room is controlled through predefined parameters, which can be packaged into an HDA and reused outside of Houdini, including in-game engines. Walls can be added, extended, or repositioned by adjusting spline controls rather than rebuilding geometry. To reconstruct a specific room, I start from a visual reference. Since there are no exact measurements, proportions are estimated visually, using standard door dimensions or objects such as a piano as scale references. Using Houdini, a procedural setup is created for walls, floors, ceiling, windows, and doors. All elements are parameter driven. Adjusting the room layout or baseboard height takes just a few clicks without rebuilding geometry. The scene is assembled using USD. Assets are stored separately and combined through a clear hierarchy, allowing elements to be replaced or rearranged without affecting the rest of the scene. For example, a door model can be swapped for another variant while keeping the same position, orientation, and material assignments. And the same approach applies to materials, allowing quick variation without rebuilding the scene. Lighting is set up to match the mood of the reference. Cold window light and warmer interior lighting are balanced to preserve depth and atmosphere, and lighting setups can be managed as variants. Common limitation when building interior scenes is storing everything as one large file. USD approach this differently. Scenes are composed of many smaller files describing transforms, references, instances, materials, lighting variants, and animations. As these structures enables parallel work. Different people can work on chairs, doors, or layout independently without loading or saving a single shared scene file. The final scene is composed through USD layers and references. The same USD scene can be rendered using offline engines such as Arnold or Redshift, as well as real-time engines like Unreal Engine or Unity, without changing the scene structure. There are some limitations. Material X is not interpreted identically across all applications, and different tools may evaluate lighting using different physics units, such as lumens or watts. In Houdini, these differences can be compensated through scripting, provided the target platform is known. Houdini acts as the main authoring hub. Other applications, such as Blender, Unity, or Unreal Engine, are used for layout, transformation, and variation management, while USD maintains the overall scene structure. This example demonstrates the approach rather than a specific solution. The same principles can be adapted to different production contexts, whether for games, films, or for other types of scenes.